All right. Are you ready? So I'm going to try to make this presentation interesting for you because you're just after lunch. So I guess you're just suffering from the food and you're almost sleeping, so we'll try to avoid that. So first of all, who is using Fluent Bit here? A few hands, okay. And who is using the OpenTelemetry Collector? All right, so you're in the right room. So welcome. Okay. Interesting. Okay. Okay, I will do it with the clicker. Oh, it works. Ooh, super great. Okay, welcome to this Telemetry Showdown. If you are looking for fighting, then you are in a good room. We're going to have some fighting experience. We have two opponents today, and we're going to figure out who is the winner, who is the best fit for your organizations. So before we go to the actual fight, let me introduce myself. My name is Henrik Drexet. I'm a cloud-native advocate at Dynatrace. So it's been almost 3 years, a bit more, that I'm working for Dynatrace. Well, otherwise, I spent the entire, almost my career doing performance engineering. So breaking things, testing things, tuning things. Yeah, having fun at the end. It was so great. And at the end, performance engineering is still in my heart. So that's why I'm one of the producers of a YouTube channel called Perfbytes. And I recently opened the French version for those who want to learn French, the performance vocabulary in French. Check out Perfbytes Français. And when I started, oh, there's a spelling mistake. When I started my adventure in the observability community, I thought, oh, yeah, let's create a YouTube channel about observability. And this is why I have Is It Observable? So check it out. It's out there. And yeah, it's free. And I need deserved feedback to get better content. So before we start, small disclaimer. To prepare this presentation, I can guarantee that no birds and no telescope has been harmed. I was really gentle with them. I did nothing, no violence, very gentle guy. Second thing is I love the Fluent Bit community, the Fluent community. They are very efficient. I love the OpenTelemetry community. They are so smart. So this session is not designed to blame any project at all. In the opposite, I want to bring value back. And moreover, I want to help the community to pick and choose which agents will make sense for your own project. All right, so let's start. So if you remember, back in the old days, we had a super great game called Observability Fighter. So let me introduce the two fighters of today. So ladies and gentlemen, on the right side corner, we have the Ryu from the Fluent Dojo. Fluent Dojo has been trained by his big brother, Fluent D, which is really good at processing logs in the bare metal environment. And then they decided to create a lightweight, speed, very efficient Kung Fu master in logging called Fluent Bit. And Fluent Bit, as you may know, recently with Fluent Bit 2.x, they started to support metrics and traces. That sounds very interesting. And then on the left side corner, we have Ryu from the OpenTelemetry Dojo. Again, very smart, very efficient. Initially started everything on traces. And then they started to cover metrics and logs, basically following the signal support from the OpenTelemetry project. So we may expect to have a support as well from Ken soon on profiling. So those are the two opponents. So let's start and see what we're going to do. So in this presentation, we're going to structure it in a different way. Similar to a fight, we'll have different rounds. The first round will be mainly focused on the design experience. Then we will jump into the logging. So what are the features we need and what are the features that they provide? And then we will look at metrics, same thing, and last, traces. And of course, at the end of the day, I did so many tests. We want to look at the numbers. We're going to see how they behave under load. And then at the end, few recommendations for you. So, round one. Design. Come on. I need you because otherwise it's going to be a very boring presentation. So, round one. Design. Come on. Oh. Round one. Ah, great. Thanks. All right. So for design. So this is basically log agents or telemetry agents, we can say. Those agents require a configuration file, and that configuration file will hold the pipeline. Because at the end, with those agents, what we want to do here is to process the information to drop, filter, enrich do whatever we want the data to just send it to a backend or several backends. So at the end, it's not a gateway, it's small, it's going to be manipulating the data. So the structure of those pipelines obviously change between the solutions. In Fluent Bit world, the name of the sections are different. So input means I'm receiving something. Then I go to another thread called parser. So I will parse the content. And then I will go to filter, another thread, that will basically do some enrichment, some dropping, whatever you want. And last, once we finish our task, we go to the output plugin where we export the data. In the collector, they have wording that are quite more obvious, of course. Receiver, I'm going to receive. Processors, I'm going to process. And exporter, I'm going to export the content. Since Fluent Bit 2.x, Fluent Bit has introduced a notion of processors. And processor is not the one that you think about, the collector, so it's not a copy of that. They decided to say, hey, what about creating a feature where when I'm receiving or before I'm exporting, having in the same thread, I can start doing things, which is smart. At the end, if you have to do some minor transformation, why do I need to wait to pass it to the next thread to do stuff? This is really smart. So this is now with the Fluent Bit design, you have these processor options, and you will see later it has a really importance, especially in metrics and traces. The collector here is the same thing, doesn't change, but we have these connectors. We'll see the purpose of the connectors later once we go into the more advanced pipelines. When it comes to processing or modifying the data, the collector basically has no impact. The way you're going to process traces, metrics, logs, and soon profiling is the same way. Receive, process, export. When it comes to Fluent Bits, it's different. So we say, why? Well, because you remember, they come from Fluent D, and they started with the same terminology of Fluent D. So in the logging space, you have a specific thread pattern where you input, you parse, and you filter, and last you go to the output. And when it comes to metrics, the parser and filter doesn't make sense. It doesn't exist. So the only way to do things is through processors. This is why processors is really important in the case of metrics and traces. And this is true since Fluent Bit 3, because Fluent Bit 3 introduced a lot of interesting features related to traces and metrics. In the Fluent D, or Fluent community, I would say, what is really efficient in the way you design a pipeline is this notion of tagging. So when you have a source, so here we have kubelet on the left side, on the right side we have a file reading from Kubernetes, and when I'm going to receive the information, I'm going to apply a tag. Here in my case, Kubernetes for Kubernetes logs. On the left side, I'm going kubelet. And the tag will have an importance because then when I go through my pipeline, I say, oh, here I'm going to filter, and I'm only going to filter all the data stream that has the tag Kubernetes. So it's like an if and else approach where you don't have to write the if then else. It's just that match and apply your changes. And then you can do match stars. For example, here I'm sending everything to Dynatrace, so everything that has whatever tag will send to Dynatrace, and everything that has kubelet will be sent to Loki in this example. So in the collector, you don't have this notion of tagging. It doesn't exist. So they recently, 1 year ago, they have introduced the routing connector. So routing connector is like a big switch. So I read some logs, and let's say we want to parse the logs differently from the Kyverno. Because Kyverno is structuring the logs, and I want to do some audits on the logs. Then with the routing, I can create a rule, if the logs come from Kyverno, go to that pipeline. So you can then process differently. So at the end, you can do very complex pipelines, similar to Fluent Bit, but at the end, you end up with a really, really big file to describe all those pipelines. So that's the small disadvantage with this structure. On the pipeline format, you have Fluent Bit used to have this TOML format, where you have the section, so input. And then in the section, you say, OK, what plugin do I want to use? So name here tail, so it means I'm going to use the tail plugin, and then I'm configuring it. And then similarly, it's a sequential approach. I do first all the parsers, and then I do all the filters, and then I end up to the output. So you're already designing your pipeline as a sequential steps. Now, since Fluent Bit 2.x, they introduced the YAML format, and I'm a YAML lover. You may say that you're crazy, but yeah, I love YAML. And in fact, why I love YAML and Fluent Bit? Because the processing doesn't exist in TOML. So if you want to do some processing, like explain, do some pre-processing tasks in the same thread as the receiving tasks, then it's only possible with the YAML structure file. So this is true from 2.x. So I will really convince you to, if you use Fluent Bit, to move to that new structured pipeline. On the collector side, it's a bit different. It's like an inventory. So you say, oh, here I have my receivers, and you just list them, and you configure them. And then, oh, then I have my processors, same thing, I list them, I configure them, so no logic. The logic will end up in this section, pipeline, where you basically define which pipeline you want to trigger, and you see here there's an order, so I'll start with processing with a member limiter, then Kubernetes attribute processor, so you're making basically the sequence. So I think from the design perspective, there's no big difference. I have a slight preference with Fluent Bit because I've been using it a lot, but at the end you can do the same thing, so there's no major differences. So I say pretty much equal on that round. So now round 2. Ah, great. Okay, round 2. So what do you expect from a logging agent? First, you need to receive the common way of exchanging logs in the environment. So obviously I need UDP, TCP, syslogs, OpenTelemetry because it's an open standard now, Fluent because Fluent has their own protocol to exchange logs. I will have Kafka because probably I will store into a queue. And then, of course, reading from a traditional file. So that's basically, if you have this, you cover 99% of your needs. And the good news is both agents has those features. If you look at the number of plugins that Collector has, it has more plugins, but I don't care. With this, I'm good to go for everything. And then what do you expect from the task you want to achieve with the logs? Well, I need to enrich my data, adding some extra metadata on the logs. I want to parse to extract some content out of the logs. I may want to drop, if there's logs that it's just noise, I want to drop it. And I want to batch, because at the end, we are sending to a backend, and there's probably a rate limit API. The API will be rate limited, so I need to batch the content. So that's basically the feature we need. And the great thing is both agents has the same features, probably named differently, we don't care. But I would say that from the parsing perspective, Fluent Bit has predefined parser for a lot of different file formats. It has EULA scripts, WASM scripts. It has tons of options. So I have still have a slight preference for Fluent Bit. Collector has a transform plugin that relies on a specific language to transform the logs called OpenTelemetry Transform Language, so OTTL, which is quite interesting as well. But the design experience is a bit rude, but I would say still you can do very complex things. So I would say for this round, I'd say I have a preference for Fluent Bit, but that's my personal feeling. I would say almost equal, even if Fluent Bit is so much popular and strong on the logging space. So equal. So let's go to the next round, round 3. Metrics. Ah, cool. All right, so the metrics, what do you expect? I need to receive metric from the common protocol, so collect D, journal D, stats D, OpenTelemetry, of course, scraping from Prometheus, collecting metrics from a host, Linux, whatever type of OS. And the great thing is everything is covered by both agents. The only difference, I would say, on the OpenTelemetry side from Fluent Bit, it doesn't support gRPC. It's only on HTTP. So keep that in mind, because it could be a challenge in your environment. Then in terms of features, of course, we want to enrich the metrics, makes sense, because I probably want to add my Kubernetes metadata on top of that. I want to drop things. And then there are metrics that are quite expensive due to high cardinality. So I want to be able to drop labels. I want to be able to reduce the cardinality. This is really important, because otherwise we don't control the actual cost of storing those metrics. And then also I want to convert. Why do I want to convert? Because there's 2 different formats of metrics in the industry. There's cumulative, so Prometheus and all those families. And there's delta. So delta is like stats-D. So if I'm scrapping some data from Prometheus and I have a backend like Dynatrace Datadog, which is delta, I will have to convert it. Otherwise, it will be rejected. So converting is like a key feature. And if you look at the table, so of course, obviously, OpenTelemetry supports everything, so that's perfect. But Fluent Bit here has introduced, since Fluent Bit 3, metric selector, so I can filter and do some data, some dropping. And then it has labels. Labels is great. I can enrich my data, my metrics, and I can also drop labels, so reduce the cardinality. So very great on that. But the only thing downside on that is that impossible to convert. So it's a pain. So if you have scraping metrics from Prometheus and want to send some on the backend on Delta, you will have to go through a collector or be creative. So here, definitely for the metric pipeline, it's going to be the collector. Collector is the clear winner, nothing to discuss about it. So let's move to traces. Are you ready? Round 4. Traces. All right, great. All right, so traces. Traces, when you deal with traces, of course, we want to be able to ingest the open standard, which is OpenTelemetry. Makes sense. But then there is still old technology. I'm not going to blame them. They are still using Zipkin, OpenCensus, and the others, so you need to be compatible with that. And of course, maybe the traces will go through Kafka queue, so I need to support that. So OpenTelemetry obviously has all the required plugins to receive, great, but Fluent Bit on the OpenTelemetry. And again, only OpenTelemetry on HTTP protocol. No gRPC. Now, in terms of feature requests required for traces, we're going to, of course, enrich. No surprise. Like you are in Kubernetes environment, we need to enrich the data. And then we have all the sampling. So I need to do head sampling, tail sampling, super important. Be able to drop. So, of course, the collector being designed by the OpenTelemetry committee has all the expected features, so that's no surprise. Fluent Bit now is moving slowly, and they're just able to add resources on top of your traces. So that's the only thing that we'll be able to do. So here, in that round, no surprise, the collector is clearly our winner. So, let's move on to the important aspects of this presentation. Round 5. Ah, great. You're following, that's great. All right, so move on to performance. So how did I structure this benchmark? Okay, I say, okay, I want to compare things, but I want to compare equally. So it doesn't make sense to compare things where the Fluent Bit doesn't have the feature, so let's do the same things. So I have designed a test, so several tests, in fact. So in Fluent Bit, I have a pipeline that's only collecting logs. Then I do a test with logs and traces, and then log traces and metrics. And I did the same with the collector. And when designing the collector, I say, oh, the file log receiver, which is a donation from ObservIQ, Stanza. If you remember, there's a log agent called Stanza. It also had some features to process. I said, oh, so basically I can process at the file log receiver, but I can also use it at the transform processor. Oh, let's do the benchmark. So I did also test on doing the processing at receiving level, and then test after receiving. So just to see if there is a best practice on that. And then the way I've designed the pipeline, like I said, so the logs, because obviously Fluent Bit has all the features, I'm going to grab the logs and enrich the data, add resources, do some parsing, and then export to a backend using OpenTelemetry Exporter. And then I'm enabling the OpenTelemetry metrics, the metrics on the agents, because I want to have some data. On the traces side, I'm basically grab the traces, add some metadata, and then export. Don't do much, because Fluent Bit doesn't support those. On the metrics, since Fluent Bit 3 supports more things, I'm collecting different Prometheus exporter, I'm adding some resources, and I am doing some reducing the cardinality of skew metrics, just to see the impact of that. So this is the 3 type of pipelines that have been designed. And then to design this environment, the way I'm going to apply load on those agents, I said, okay, if I generate load on applications, then those applications will write more logs, and they will produce more traces. So it will be naturally a way of stressing this signal. So for the Fluent Bit architecture, I have a daemon set to collect the logs. I have the OpenTelemetry demo. I'm used to generate traces. I have the hipster shop to generate traces as well, so I have 2 load tests there. And then I've added some exporters, Prometheus exporters. So I have the traditional kubestat metrics node exporter. I've added Istio to add all the envoy metrics as well, and all the envoy traces and logs. And then also, I intentionally use Kepler, which is an amazing project, but it has a downside. It's a super high cardinality exporter, so it's the bad guy in the test. We know that it's going to be put pressure on our environment. So that's why I have Kepler there. With the collector, because in Fluent Bit, I have added a collector. Why? Because I need to transition protocol. You remember, it doesn't support gRPC, so I'm going through a collector, switch protocol, and then send to Fluent Bit. On the collector, you don't have Fluent Bit, obviously. It's the same architecture with the daemon set deployment for the collector. And then, before we go to the results, I did two rounds of tests. So ramp-up tests, 2 hours, where I'm at 50 users on hipster shop and OpenTelemetry demo. So after 2 hours, I have 200 users on the hipster shop and the OpenTelemetry demo. And then I do a soak test of 24 hours, constant load, 50 users on each application, just to see how the memory is consumed. So let's look at the ramp-up test with only logs. So here we can see that we have this is the log coming in the system. So you can see that it's following the ramp-up of the application. The graph on the bottom is the CPU usage in millicore. Fluent Bit is about 60 millicore, 60 to 80 millicore. The collector is about 100 to 90 millicores, and then start to reach almost 200 millicores. So the CPU usage is a bit better, I would say, for Fluent Bit. And then you have the memory usage. So here, Fluent Bit is about 15 to 20 megs, and the collector is about almost 100 megs. So we have an 80 megs difference between the two agents. Then I introduced the traces. So traces on you see the incoming traces in the systems on the top right. The CPU usage has been increased a little bit, but still there's an advantage on Fluent Bit. Better CPU utilizations. And on the memory, same thing, everything is stable. Still 80 megs difference between the agents. And now I say, let's move on and add metrics with Prometheus exporters. So here you have the metrics, which is, we have more 500,000 metrics coming in during the tests. And we can see that the Fluent Bit is about 100 to almost 200 millicore. And the collector, if you look at the memory here, it's even more impressive. So Fluent Bit was about 40 megs, and the collector reached about 3 gigs of memory usage. And then you can see that the CPU is related to the garbage collector, obviously, so it's consumed lots of CPU, almost 600 millicore. And I said, okay, interesting. That sounds like a great memory leak, so let's do the soak test to figure out. So here's the soak test result. So here you can see the memory consumption of the collector, so you don't even see the Fluent Bit because it's still super stable at 40 megs. And the collector reached out 10 gigs, crash, restart, 10 gigs, crash, and the CPU reached almost 2 cores of consumptions. And then I tweaked the Go runtime to have a better GC, so instead of crashing, it's still there, but the memory is flying on the roof. So I said, it seems like a bug. So I opened a GitHub issue and say, oh, that sounds like a Prometheus receiver. So that's my first reaction. Oh, it's Prometheus, it's for sure. And then I did some pprof files and we exchanged. And I want to basically submit a talk for KubeCon to unbound those recommendations. It seems that it's related to, again, remember Kepler with high cardinality? This is the one that put pressure, because I did test it with different exporters, and it was not the case. And specifically when you use cumulative delta. So Prometheus in conjunction with cumulative delta, if you have a hard coding metrics, beware. So I said, okay, I need to confirm to the community that it's only the metrics and nothing else. So I did a soak test with only logs, and the soak test only with log and traces. And here you can see CPU utilizations and memory utilizations of the collector, super stable, so no memory leak. So obviously it's the metric. So metric is responsible. So I said, okay, but I don't want to stop by benchmark here. I want to continue. How can I delegate the metric collections with the collector? So there's a great project, which I love, from the OpenTelemetry community called the OpenTelemetry Operator. And the OpenTelemetry Operator introduced a feature called the target allocator. And I thought, oh, why don't I use it? So if you don't know, not aware of that feature, it's that basically you have in your collector pipeline some scrap config. You can also collect the pod monitors and service monitor, by the way. And then what it does is it takes the scrap config, and basically it will send it to the target allocator, so you have a new workload. And that workload will be the metric discovery. So it will discover all the metrics, and then you say, oh, how many replica do you have? Okay, 3. Okay, so I'm going to split equally the jobs. And then the collector at the end doesn't do the metric discovery anymore. He's basically going to do the HTTPS deconfig from Prometheus to say, hey, give my metrics, give the metrics, give the metrics. Very simple for the collector. So I say, okay, let's try out with the target allocator to figure out if I have improvements. So the environment is the same, but I introduced a metric collector in this environment. And I didn't show here, but there's the target allocator service the pod will be added. So same test, 24 hours, but now with the target allocator. And I have enabled tons of pod monitors as well. So I have even more metrics than we had before. And here you can see that the metrics, the memory utilization of the collector is about 600 megs on the same test. And the CPU utilization, 200 millicore. Wow. And then I look at the target allocator, it's 10 millicore of usage. And the memory, 60 megs. I say, okay, interesting. Which means by adding more workload, in this case, it's target allocator plus all the collectors, I'm consuming less resources. So if you're operating collectors in your Kubernetes environment, I highly recommend to use the OpenTelemetry operator for that and enable the target allocator because it's is just a fantastic feature for metric collections. Last piece before we close this talk is the processing. Remember, I did the test before and after. Where should I process my logs, or my logs in this case? Is it on the file log receiver or in transform? At the end, I did a lot of tests. You don't see it very well because it's small, but at the end, there's a small advantage with transform. I was surprised. But it was really almost nothing. And then I look at the processing time, and at the end, no differences. It doesn't bring any difference. The only recommendation I would give you is that if you have to process things, process it always upfront. So if you have a chain of collectors or Fluent Bit, do the small transformation on the way, avoiding sending everything to a big chunk of collector or Fluent Bit that will suffer from your transformation. So that's basically my recommendation if you have to deal with large pipelines. So as a conclusion, I would say for logs, if you're just dealing with logs just because of the resource usage and the way Fluent Bit is processing it, go for Fluent Bit. It's an amazing agent. It's been proved. The community is awesome on that side. But if you have to deal with other signals, metrics and traces, the collector. It doesn't make sense to have two agents because you will have to have all the skills of all the design of pipelines for Fluent Bit and the collector. So go for the collector, but just control those constraints and work with them. And that was my main recommendation about it. Small teaser from my YouTube channel. Is it observable? So there's plenty of content. I have an episode going deeper on this benchmarking. I have an episode about the metric format, cumulative delta, the operator, the target allocator, blah, blah, blah. So check it out. Scan it, watch it. If you like it, like it. If you hate it, just let me know, because if I don't know that you don't like it, I won't be able to improve the content. So thank you for taking the time to be with me for this presentation. And if you have any questions, I'm very excited to answer your questions.
Hello. First of all, thanks a lot for your talk. I'm from Splunk and I enjoyed your talk a lot. So I want to ask you, have you tried to send metrics using OTLP instead of exposing it using the Prometheus?
So I had few metrics in OTLP, but obviously here I have exporters, so I didn't want to, there's so many solutions exposing just Prometheus exporters, so at the end the user will do that. So I say I will put my shoes into an end user that will obviously collect metrics from a Prometheus perspective. But yeah, obviously with the OpenTelemetry metrics, I don't know if that will change or not the memory leak that we discover, because I didn't do this.
Okay, yeah, because you know that Prometheus also underset OTLP right now. And
yeah, on the agent mode, but I'm more referring on the Kepler or Istio that are exposing the metrics. They don't, so I have to scrape those data.
I see. I also have a second question, if I may. Have you analyzed if there's a big performance difference if people are sending the logs basically using OTLP like protocol compared to std out? And you know, what is the difference using the performance compared to parsing the files, for example, from syslog or whatever, and comparing it to, you know, using HTTP basic even on localhost?
So if I understand you well, you are asking me to do that test. Okay, so I'm making a to-do list now. No, so I didn't do that test, but I think it's interesting tests, because at the end, the file we are parsing is string or similar. So the processing is more expensive. And if you have a pre-structured log, then it's more easier to parse it. That's the normal human reaction. But you never know until yeah, that's true. So yeah, it's a good point. It's a good point.
Thank you.
Any other questions? While we get into this question, I also did the similar test with vector as well, to compare vector as well in this, and it was also interesting about that.
Yeah, thanks a lot for the presentation. Very interesting. The memory leak you showed, is that going to be fixed, or is like the permanent solution to use the operator to avoid that memory leak?
So it's not fixed. We are under investigations. We just know that it's the cumulative delta, and also the way you define the scrap config could have a significant impact on the collector. So that's why we want to do, I hope I will be able to present that, but I want to do a study on the different settings that may impact or not the collector, or here it's the collector story. But at the moment, I think it's this issue that we saw on screen, it's a mix of a bad user, me, and probably some problems on few processors. So I think it really depends on if you're designing not properly your pipeline, you could have some surprises. So I think it's also good to have some testing when you design those telemetry pipelines.
Okay, thank you.
Thank you very much for a great talk. I wanted to ask about the aspect of the unified spec. So comparing two ingestion tools versus one on the performance side is nice, but there's also the enrichment, the ability to support the correlation. So I'm wondering if you can address this aspect as well.
Yeah, so in the logs I did this, I used the Kubernetes attribute processor, and on the Fluent Bit has the similar feature, so I used the similar enrichment to be able to index more the logs. On the metric side, because Fluent Bit didn't have that feature, I did some few enrichments manually because they don't have the Kubernetes attribute processor supported yet. So I did some, but at the end I didn't see major impact in the enrichment to be able to correlate and index the data back in your backend. On those agents, it's more like the data is bigger, but in terms of footprint, it doesn't change much.
Yeah, just to clarify, my question is not about the performance or footprint, it's just about the enrichment that you did manually. I think it's important just to emphasize to the rest of the audience, it is something that you get out of the box if you use OpenTelemetry Collector, then you get a uniform enrichment and a standardized one that can then support the correlation, whereas you needed to do that manually. So just when we compare a unified OTel collector versus OTel plus Fluent Bit, there is an extra manual work that you need to make sure that you use consistent semantic conventions across the signals.
Agree. I mean, if you collect any data, collecting is one thing, but then you will send the data to a backup, so it's like a storage. If you don't have this semantic convention in place on your data, it doesn't make sense. So it's really crucial aspects when specifically when you design the pipelines, because at the end you will just have a chunk of data and then you don't know how to index it and correlate those data together. So it's a good point for that. Any other questions? All right, so thank you so much for your time.